Hey, we're the Interactive Alphabet Wall team. My name is Ulysses. So in this project, what I did mainly was focus on the hardware development of the smart holds and also aided Landis in a little bit of the Bluetooth development of the application. And he did mainly the application development for our project. We have Mason right here who focused on embedded software development of our gateway. And then we have Alex who focused on the mechanical design of the handholds and also focused on the embedded software development of the smart holds themselves. So what our project does is it tries to resolve the problem of childhood obesity that is becoming an epidemic in the United States, especially through ages between 4 and 8. Kids are spending less and less time outdoors and they're living less healthier lives. And so what we tried to tackle was create an interactive game that provides some kind of educational benefit, but at the same time getting kids more active and getting outdoors. And we did that by designing smart holds that go on existing climbing walls that a teacher and a student can interact together. So the teacher will pick a word and the student will spell the word on the climbing wall.
So as far as our system block diagram goes, so we have a smartphone application that connects to our gateway subsystem via Bluetooth Low Energy. Our gateway subsystem also communicates with our smart handholds using the LoRa long-range wireless protocol. Our gateway consists of not only those two radios, but also a dot matrix display that's used to show the word progress as the climber climbs across the wall and spells it. And then our handholds, in addition to the LoRa radio, have a dot matrix display as well to display the letter that's been assigned to it, a button so that the climber can select that letter for part of the word to spell, and the smart holds are also powered by 4 AA batteries.
Now I'll show you kind of the functionality of our wall. So we have a smartphone application that communicates with this gateway device over here. And this gateway talks to all of our handholds to give them a letter to assign. So at the beginning of a game, you select a word and we'll select a random word from our app. So the word is think. And then you can begin the game and each of these handholds gets assigned a letter. So now the teacher has given the student a word to spell and they can go climb around the wall and start to spell the word. So the word is think, so we start T, and then H, I, N. And as the student spells, the word is updated on our display over here so they can see their progress. It's also updated on the application to show they're spelling the word correctly. And then the final letter is K, and we get a winner on the screen, and on the application it is shown that the word is completed and spelled correctly.
So the biggest challenge for me with developing the smartphone application was learning the nuances of the Android development environment from a basic knowledge of Java. I was able to implement the game screen to update status, word statistics, the ability to load custom dictionaries from a JSON file, among many other features.
Since I was mainly focused on the embedded hardware development, the biggest challenge for me was trying to make sure that the smart holds that we were creating were completely assembled and sturdy enough to fit onto our demo wall. And then at the same time, I helped Landis with the Bluetooth discovery phase of the application development, and starting from scratch of zero application development experience, learning all the hoops and the different APIs that were used in Android development to enable that. That was a pretty big learning curve for me when I was designing this project.
The biggest challenge I faced was working with the networking and making sure all of the packets that we sent out wirelessly were robust and were able to be received and guaranteed the reception of them.
Working on our gateway subsystem, the largest challenge that I faced was figuring out how to get both a LoRa and a Bluetooth radio working on the same board at the same time. There were a lot of conflicting pin assignments and things in the libraries that we were using, so had to go in and modify those in order to make sure that the resources on the part were shared correctly, as well as figuring out how to get all of those integrated into a real-time operating system so that our system would run as smoothly and efficiently as possible.